Hey, what's going on everyone? This is Hui. Welcome back to the channel. Since today's video, I'm going to share some audio and video knowledge of iOS development. I believe that everyone knows about audio and video, but not everyone really understands what it is, how audio and video works, how we develop on it. I hope that my video can help more people become specialists instead of simply calling the third-party libraries. Okay, let's get started. So first of all, let's take a look at the formats of the video. This includes the video format and the codecs format. This is the basic common sense we need to know in the video development. About the video file format, what we often say is, for example, MOV, MP4, AVI, MKV, RMVB, etc. Why are there so many video formats? Isn't one video format enough? This is because there is the concept of the video container format. The video container format, also known as the video file format, it is similar to a container or wrapper of storing video information. We can think of it as a container for drinking water. Some people like to use a tumbler, some like to use a cup, and some like to use a mug. Same to the video files. There are various containers for storing the video. What information does the video container contain? It contains video, audio, and some related configurations. The configurations tell us the relationship between video and audio, their time tracks, and how we decode it. We call this information as metadata. Here is a table of common video format and the corresponding file format. I won't go through all of the details because I think this table is pretty clear. I will just briefly show you a few common ones. For example, the AVI format. The AVI format was introduced by Microsoft. Its advantage is that the video quality is very good. It is lossless and saves the alpha channel. But its downside is that once the quality of this video is good enough, its size will become very large, and its compression standards are not uniform, so it will cause many compatibility problems between versions. Then next, WMV. This format is used very much on the network. It is also developed by Microsoft. It uses an independent codecs method. It is generally used for live videos, because in the same video quality, the WMV format supports playback while downloading. And then MPEG. In MPEG, you are most familiar with MP4. There are currently 3 compression standards: MPEG-1, MPEG-2, and MPEG-4. The MPEG-4 is the one we use the most. Its advantage is it uses the smallest data to get the best image quality, and the QuickTime file format. It is developed by Apple. The default player is Apple's QuickTime. The file format is .mov. Of course, it also can be played by other players. The advantage of QuickTime file format is it has a higher compression ratio and better image clarity, and it even allows us to save the alpha channel. You know, normally, when we do video compression, we usually have to close the alpha channel. The rest of them you can research by yourself. These points of knowledge seem to be just some common sense, but if you have further development in audio and video field, this basic knowledge is very essential. These are the main video formats. Then, what is a video codec? What is it doing? Actually, encoding and decoding is the process of compressing and decompressing of video or audio data, which according to a certain rules. This process It's called Codec. The compression is actually to remove some redundant data. I will tell you what information is redundant and how we work on that in the future videos. We only need to know right now is what factors should be considered about when we are working on that, such as the video quality. We cannot compress it too much. It will cause the video not able to watch. We also need to consider the video data amounts, that is the bit rate per second. And we also need to consider the complexity of the encoding and decoding algorithm, as well as the robustness for data loss and errors, and the editing convenience, random access, end-to-end latency, and so on. All these factors will ultimately determine our encoding and decoding methods. The common codecs methods are based on H.264, and H.264 is the one of the most commonly used formats. For the recording, compression, and distribution, it supports resolutions up to 8K. The H.264 is also be called advanced video coding. Additional advantage is it provides enough flexibility to allow the standard to be applied to a wide variety of applications on a wide variety of networks and systems, including low and high bit rates. Okay, as we know, H.265 is designed as a successor to the widely used H.264. It offers better data compression at the same level of the video quality, and substantially improved video quality at the same bitrate. But why don't we choose H.265? Although H.265 is the trend in the future, there are two issues here. First, H.265 is only be supported on iOS 11 and later. In some cases, you need to take care of some relatively old devices. Second, when we use H.265, the device needs a lot of CPU power. The heat of the CPU will be higher. Choosing H.264 or H.265, it mainly depends on the requirements of your project. In terms of the current network environment and the user experience, H.264 is perfectly sufficient. Okay, let's take a look at what is audio codec formats. Like the video files. Video files have video codecs, such as H.264. Audio files also have audio codecs, because audio and video are two completely different things. They need to have their own codecs. One for the pictures, another one for the sound. They are not the same thing. Regarding the compression of sound, these three are more common. In the live videos or short videos, the most commonly used is AAC. It demonstrated greater sound quality and transparency than MP3 for files coded at the same bitrate. The rest of them you can take a look by yourself. I have also added the description for MP3 and WMA. And now I would like to summarize what we learned today. So first, what are the advantages of H.264? Number 1, low bitrate. Number 2, high quality images. Number 3, powerful robustness feature for any errors and data loss. Number 4, it provides more flexibility for application to a wide variety of network environment. And number 5, H.264 has very high data compression ratio. Its compression ratio can reach an amazing 102 to 1. For example, if a file with an original size is 102 gigabytes, when it's compressed with the H.264, the file size will be reduced to only 1 gigabyte. This is completely sufficient for our nowadays network environment. About AAC. It is currently the most popular lossy compression codecs. It defines 3 profiles: LC-AAC, HE-AAC, and HE-AAC version 2. LC-AAC is a traditional AAC. It mainly used for medium and high bitrate coding. And HE-AAC and HE-AAC version 2 are mainly used for low bitrate coding. The biggest advantage of AAC is it performs particularly well at code rates of less than 128 kilobit per second. It is mostly used for audio codecs in the video, such as live videos and short videos. However, in the music type apps, like Spotify and Apple Music, we normally use MP3 or WMA format. Further than that, we even can use the lossless format. Alright, this is gonna be for today's video. Hope you enjoy it, and I will see you guys in the next one. Stay tuned.